Welcome to this explainer. We've all stood on the sidewalk as a garbage truck rumbles by, right? And usually we just see a loud, smelly metal box that makes our trash disappear. But today we're going way past that metal exterior. We're going to explore the highly pressurized, highly specialized engineering behind modern Chinese sanitation vehicles. These things are absolute marvels of mechanical force, material science, and strategic design that literally keep our global cities running. So let's dive right in.
Here's our roadmap for today's explainer. First, we'll look at the heart of the machine. Then we'll break down the 4 classifications of trucks. After that, we'll see how they conquer the collection route. And finally, we'll wrap up with steel, specs, and sourcing.
All right, starting off with Section 1, the heart of the machine.
It's a fascinating question, isn't it? What actually powers the beast that crushes your weekly waste? You might be wondering how a relatively standard commercial truck engine generates the sheer immense force needed to compress tons of dense refuse without just stalling out entirely. Well, it's not magic. It's a brilliant piece of mechanical engineering.
And the answer lies in the Power Takeoff System, or PTO. Think of the PTO as the biological heart of the truck. When the driver shifts into a dedicated collection gear, the PTO mechanically links the truck's transmission straight to the primary hydraulic pump. It essentially hijacks the rotational power of the engine and uses it to pump highly pressurized hydraulic fluid right through the vehicle's veins.
And when I say pressurized, I mean extremely pressurized. We're talking fluid operating at massive pressures, frequently exceeding 2,500 psi. To put that into perspective for you, a standard car tire sits at about, 35 psi? This 2,500 psi fluid is exactly what forces those heavy-duty, multi-stage cylinders to maneuver massive compaction blades in internal ejector panels against the severe resistance of literally tons of compressed trash.
So, here's how it all comes together. When the PTO engages the pump, fluid floods those massive multi-stage cylinders. This triggers a mechanical sweep and slide motion, basically scooping the raw waste into the body. All the while, the internal ejector panel pushes back like a moving wall. This provides a continuous back pressure, ensuring everything is packed down as tightly as physically possible.
Now, you'd think this heavy, grinding process takes a long time, right? But incredibly, thanks to some really precise hydraulic valve calibration, this entire mechanical compaction cycle finishes efficiently in just 15 to 20 seconds. It literally consumes, crushes, and resets in less time than it takes to tie your shoes.
Moving on to Section 2, 4 classifications of trucks. As you know, you can't just use one tool for every job. Looking at this breakdown, we have rear loaders for urban density, side loaders for the suburbs, front loaders for commercial bins, and hook lifts for construction debris. If fleet managers pick the wrong configuration, it causes premature structural fatigue and massive inefficiencies. You really have to match the truck type, the compaction ratio, and the operator set up perfectly to the specific environment.
Let's look a little closer at the heavyweight champion here, the rear loader. This is absolutely the global standard. It uses its immense 6-to-1 compaction ratio and integrated bin lifters to just crush dense, mixed residential waste. When you picture a classic garbage truck in your head, this is probably what you see. It's capable of chewing through almost any bulky household waste you throw at it.
On the flip side, we have the automated side loader, or ASL. This one is a highly efficient suburban specialist. Instead of a whole team of loaders hanging off the back, it features a single-operator robotic hydraulic arm. The driver stays safely inside the cab the whole time. This dramatically reduces municipal labor costs and entirely eliminates the physical strain of workers manually lifting bins all day long. For uniform curbside routes, it is absolutely a game changer.
Which brings us to Section 3, conquering the collection route.
Strategically deploying these specific vehicle anatomies is basically like playing an urban chessboard. Deploy the wrong truck and you're looking at severe route delays and broken equipment. For example, if you're navigating a narrow urban alley, you're going to need an agile, light-duty rear loader on a 4x2 chassis. Servicing an industrial park, you need a front loader to lift those static factory dumpsters. And in a construction zone, you absolutely have to use a roll-off truck. If you try putting heavy demolition concrete into a standard rear loader, well, you will instantly destroy that internal compactor.
And finally, Section 4, steel, specs, and sourcing.
Let's dive right into the DNA of these vehicles. Think about the chemistry of garbage for a second. Raw municipal waste is highly acidic. It's basically a corrosive liquid soup mixed with abrasive solids. Because the hopper floor faces this daily nightmare, standard mild steel simply won't survive. It rusts and warps rapidly. So top Chinese manufacturers absolutely must use extreme high-tensile, wear-resistant structural steel grades like NM450 or Q690. Without this advanced material science, the vehicle would literally fail on the route within months.
The specialized steel superstructure is then paired with specific commercial chassis. These manufacturers source from trusted heavy-duty brands like Sinotruk or Dongfeng. The setups scale dramatically too. You might start with agile 4x2 setups for light 5 cubic meter bodies meant for paved city streets. But if you're hauling a massive 25 cubic meter payload directly into the unpaved muddy terrain of a landfill, you have to scale all the way up to heavy 6x4 or 8x4 multi-axle configurations. You need that just to maintain traction and distribute the immense weight.
And before these machines ever hit the global market, they undergo some seriously rigorous testing. Chinese factories test these units under extreme pressure to ensure those hydraulic hoses are entirely leak-free. They also custom program the engine outputs to perfectly match specific regional emission standards. So, whether a unit is heading to a developing market that requires Euro 2 standards or a strictly regulated urban zone requiring Euro 6 compliance, the vehicle is completely tailored for its new home.
It really changes how you view city infrastructure, doesn't it? When you realize the complex, pressurized mechanics, the strategic route planning, and the advanced material science hiding just beneath that steel plating, it's hard not to be impressed. So I'll leave you with this. The next time a sanitation vehicle rumbles down your street to efficiently clear away the waste, will you just see a simple trash truck? Or will you see a 2,500 psi, high-tensile engineering marvel keeping modern civilization running? Thanks so much for joining me on this explainer today.